go for another one. So here we have to find Fourier sine series expansion for the function fx, which is given by minus 7x plus 9 defined from 0 to pi. So your function fx is minus 7x plus 9 defined from 0 to pi. So as usual, first step is to find L. So we write, as we know that the Fourier sine series is, what is it? It is fx equal summation n from 1 to infinity bn sine n pi x over L. So first step is to find L. So to find L, first we find the length of the interval 0 to pi, which is pi minus 0. That is pi. Now comparing it with this Fourier series, this is Fourier sine series for the function f of x, which is defined from 0 to L. So comparing this, we get L is equal to pi. Now substitute this value L here. So it is n is equal to 1 to infinity bn sine n pi x over pi. Cancel pi with pi. So the Fourier sine series is n from 1 to infinity bn sine of nx. Okay. Now what is left? To find bn. So bn is given by 2 over L integral 0 to L fx sine n pi x over L dx. This is the formula for bn, which is given by, now substitute 2 over L, L is pi, integral 0 to L, our interval is from 0 to pi, fx is minus 7x plus 9, minus 7x plus 9 sine of n pi x over again L, which is pi dx. Before moving to integral, just simplify it. So we left with, what we'll get? Let's use another page, bn, which is 2 over pi integral 0 to pi minus 7x plus 9 sine of nx dx. Now next is to integrate it. How do we integrate? Again, it's product of two terms, integration by parts, because we have rule for both of them. So integration by parts, and one of the function is algebraic function. So you can use again that method. Select one function which is algebraic function for derivative, another function for integration. Again I am saying, if you use UDV method, you will get the same result. It's not wrong. You will get the same. So for derivative, we select minus 7x plus 9 integration sine nx. Derivative is minus 7. Its derivative is 0. Integration of sine, cosine of nx over n with minus. Here minus sine nx over n square. Then we have to put the signs to collect the terms together. We start with first sign plus, minus, plus, and multiply and cross. So there will be two terms in the expansion. So let's write it down. So bn equal 2 over pi. So this is a bracket here. Plus minus gives you minus 7x plus 9 cos of nx over n. Now again this is minus. Minus become plus, and then again minus become minus. So it gives you minus 7 sine nx over n square, and limits is from 0 to pi. Okay, then how do we do it? We just substitute the limits. So 2 over pi minus, replace x by pi. So 7 pi plus 9 cos n pi over n minus 7 sin n pi over n square. This is when x is pi. Minus, replace x by 0, minus 7 times 0 plus 9 cos of n times 0, which is 0 over n, minus 7 sine of 0 over n square. This is the term. Now let's see, this is 0. Cosine of 0, the value is 1. Sine of 0 is 0. This cancels this entire term. We know that sine n pi is 0 and cos n pi is minus 1 to the power n. So let's rewrite it. So we take this minus sign inside. So it gives you 2 over pi. Minus minus become plus 7 pi. Plus minus become minus 9. Then the bracket will be same. Minus 1 to the power n over n. This term is 0, so this entire term cancels to 0. This minus minus become plus. Plus, this is 0, we have 9 over n. And the last term is already 0. So this is the value of Bn. Substitute now this value of Bn over here. We get the corresponding Fourier sine series. So we get fx is equal to summation n from 1 to infinity. Sorry, Fourier sine series. So what is it? 2 over pi 7 pi minus 9 minus 1 to the power n over n minus plus 9 over n times sine nx. So this is Fourier sine series for this function.